this video, we cover the time value of money, a concept critical to understanding how money works and how it should be managed, especially in situations that involve cash amounts to be received or paid in the future. Whether these cash amounts present themselves in day-to-day living situations or in a variety of different business settings. At the end of this course, you should be able to define the time value of money, compute the future value of a cash flow, compute the present value of a cash flow, compute the internal rate of return of a cash flow, explain important personal and business applications of these concepts, and list the factors that determine interest rates. Okay, let's start at the very beginning. A dollar received today is worth more than a dollar received tomorrow, or for that matter, any time in the future. In today's economy, the use of another person's assets comes at a price. For example, if you use another person's apartment, you pay a monthly fee called rent. Or if you rent a boat for the afternoon, you normally pay an hourly fee. Money, which of course is also an asset, has its own price. If you use someone else's money, like borrow from a bank, you pay a fee called interest until you return the borrowed funds. And it is this element of interest that creates the time value of money. Let's begin by assuming that you deposit $100 in a bank that pays an annual interest rate of 8%. That is, you loan the money to the bank and it pays you interest until you withdraw the funds. If you leave the money in the bank for a year, it would grow to $108. $100 times 1.08. Or $100 times 1 plus the interest rate, which in this case is 8%. If you leave it in for a second year, the $108 would grow to $117. 108 times 1.08. That is, the $8 of interest earned in the first year earns interest in the second year. This process is called compounding, leading to what is called a compound interest rate. Interest is earned not only on the $100 principal, but also on the $8 of accrued interest. Leaving the money in the bank for a third year would have it grow to $126, $117 times 1.08. The $17 of earned interest up to the end of year 2 earns interest during year 3, and the compounding continues. Here's the general formula describing how much a single sum or dollar amount would grow to in the future, given an annual interest rate R, invested for a given time period in years N. The future value of the investment is equal to the single sum invested multiplied by 1 plus R, the interest rate, to the nth power, the number of years. To illustrate, $100 invested at 8% for 1 year grows to a value of $108, $100 times 1.08. $100 invested for 2 years grows to a value of $117, $100 times 1.08 times 1.08. And $100 invested for 3 years grows to a value of $126. $100 times 1.08 times 1.08 times 1.08, 3 times, once for each year. Let's conduct the same basic exercise, but change the interest rate to 10% per year. Investing $100 at 10% for 1 year would grow to $110. leaving the 110 amount to grow for a second year would lead to $121. And then the 121 would grow to $133 if left for a third year. At this point, a couple of important observations are in order. First, the time value of money is the difference between the $100 investment and the amount it would grow to under the various combinations of interest rates and time periods. Note that its size or magnitude depends on two factors: the size of the interest rate, 8% versus 10% in this example, and the length of time, 1 year to 3 years in this example. The time value of money becomes larger as the interest rate increases. The time value of money is larger across all 3 years for the 10% interest rate than it is for the 8% interest rate. The time value also gets larger as the time period gets longer. The longer you leave the money invested, naturally, the larger the dollar amount it grows to. Finally, there are tables as well as easily accessible aids that help make these calculations much, much easier. Let's look at the tables first so you understand where the numbers are coming from. Here's an example. This table, entitled Table 1, the future value of $1, is used to compute the future value of a single sum or dollar amount invested at a given interest rate for a given time period. It includes the factors that should be multiplied by the single sum when computing the future value, which is how much the investment will grow to. It contains rows representing various time periods, N, and columns representing various interest rates, R. For example, the table factor corresponding to an 8% interest rate compounded over 3 years is 1.25971. This amount is exactly what we found when earlier we multiplied 1.08 times 1.08 times 1.08, 1.25971. 1 plus r, 8%, to the third power. To illustrate the entire calculation, $100 times 1.25971, the factor from the table corresponding to an r of 8% and an n of 3, equals $126, the future value of the $100 investment. Thus, these table values are simply the factors that emerge when applying the formula 1 plus r to the nth power. The formula multiplied by the single sum invested when computing how much the investment will grow to, given an interest rate r and a time period n. Alternatively, instead of using the table, you can use any of a variety of pre-programmed aids that automatically calculate for you the future value of a single sum. Most spreadsheets, for example, Excel, and many calculators contain this function. In these cases, you simply input 3 pieces of information: the dollar amount invested, the annual interest rate, and the time period. For example, if you input $100 as the dollar amount, 10% as the interest rate, and 3 years as the time period, the aid will compute for you a future value of $133. 100 times 1.10 times 1.10 times 1.10, or $100 times 1.331, or $100 times 1.10 to the third power. All the same thing. Now that we have covered the fundamentals of future value, let's consider our first review question. The future value in 1 year of a single sum is equal to A, the single sum multiplied by the interest rate, B, the single sum divided by the interest rate, C, the single sum multiplied by 1 divided by the interest rate, or D, the single sum multiplied by 1 plus the interest rate. Take some time now and make the correct choice. The correct response is D.